wabarakatuh and good morning. So in this video we discuss the tutorial 3. For tutorial 3, I think I will divide into few videos kot supaya dia tak panjang sangat lah. So we're gonna start with question 1 until number 6 for the first part. Okay, question number 1. Which of the following statements regarding electric conduction is not true? Okay, you can read the answer. Current flows from low electric potential to high electric potential. That one is not correct. The direction of drift velocity of electron is always opposite to the direction of electric field. That one is correct. Example, if you guys still remember from our model of microscopic model of electron, so you know that this one will be a positive terminal, this one is negative terminal. So if I want to draw my electric field, it will be in this direction. So electric field in that direction, while on the other hand I have electron that will move in this direction. So my electron will comes out from here, they will move something like this. So the drift velocity will be pointing in this direction, v drift, which is basically just the v average. So that one is correct, opposite to the electric field. Unit for current is ampere, correct as well. A coulomb is equal to 1 ampere multiplied 1 second, that one is correct as well. So the answer would be A. Okay, question number 2. Which of the following statement about electric current is not true? So actually I changed the answer a little bit. So obviously that one is the answer lah. Question number 2A. The current is defined as the rate of flow of either electron or positive charge current. Okay, that one is correct. The direction of electric current is always towards the higher electric potential. Okay, this one is wrong. Same answer with B. Sorry, same answer with question number 1. So it is actually moving from high to lower potential. The current in a conductor is directly proportional to the potential difference across the conductor. That one is correct. That one is from Ohm's law. The current in the circuit is driven by electromagnetic force within the circuit, correct as well. So that one is EMF. Question number 3. So question number 1A, question number 2B. Question number 3. The potential difference across the ends of a wire is double of in magnitude. If Ohm's law is obeyed, so Ohm's law is obeyed means resistor does not change with respect to temperature, so it's a constant value. Which one of the following statements concerning the resistance of the wire is true? So the resistance is not changed, so that was the answer. So if you guys still remember, the factors that affect the resistor would be temperature, you have cross-sectional A, and then L, and then rho. Okay, this is the thing that we change the quantity, the values of resistance. Okay, next question. Question number 4. A simple series circuit contains a resistor R and a battery. If a second resistor is connected in parallel with R, what will happen? So if you connect another resistor in parallel with R, example like this, you have so initially it is like this, okay, but now they're connected to another one more resistor. Maybe I can draw this one like this so that you can see clearly that this one is parallel. So if you have increase of resistor in parallel, you actually decrease the resistance. So question number 4, what will happen with is resistor will decrease, resistance will decrease, and then if you are using V equals to IR, okay, if resistance is decreased, the total current will be increased. Okay, you expect that the V will remain constant lah. So let's say V equals to 6 contohnya. So the V the 6 volt remain the same, but now you have decrease in resistance, you will expect the current to increase. Question number 5. The potential difference across the terminal of a battery when it is not connected to a circuit is called B, electromotive force. Okay, that one is for the objective question. For question number 6, okay, this one is a simple question. A copper wire carries a current 2 ampere. So first thing first, you take out the information. So I equals to 2 ampere. The time is 20 seconds. Calculate the charge flow through the wire during this time. So they want to find Q. So you know that initially I equals to Q over T. So if I rearrange this one, Q equals to IT. So I can substitute the values of 2 and 20. So that one will be 40 coulomb. So make sure you write the correct unit. The charge will be in coulomb. So that's for A. For question B, the numbers of electrons passing through the wire during this time. So you already have the charge. I can relate with equation of Q equals to N E, where N is numbers of electron. So basically I want to calculate my N. Charge per electron. So it will be 40 divided by the constant charge, which is 1.6 times 10 to the power of negative 19. Okay, you have to press your calculator, and I think you should get 2.5 times 10 to the power of 20. So logically you will think that the numbers of electron is a lot lah, ada banyak electrons during that period, 20 seconds. Okay, the number of electron per second passing through the wire during this time. So basically the question want to find N divided by T, numbers of electron per second. So the time is already given, which is 20. So you just have to divide that one with the time, which is 20. 1.25 times 10 to the power of 19. Electrons per second. Okay, alternatively, you can write S minus 1.